Welcome dear students. Today we are going to discuss carbon and its compounds from class 10. First of all, here we will discuss what is the nature of carbon element. Okay, what is the nature of carbon element? Carbon is typically a non-metal. A typical non-metal is there. Okay, and it is present in the earth crust to the extent of 0.02% by mass. So, carbon is typically a non-metal. What is the nature of carbon? Carbon is typical non-metal which is existing as 0.02% by mass. Now, in this chapter, carbon and its compounds, what we are going to study is basically the hydrocarbons and the compounds that are made by carbon. Okay, so here we are discussing about the related terms and all about carbon. So first of all, you should know that in air, what is the composition of carbon dioxide by volume? In air, carbon dioxide is present with a composition of 0.03% by volume. Is it okay? Everyone knows this? So, here are few points which we are going to discuss. Carbon compounds are mostly covalent in nature. Carbon compounds are mostly covalent in nature. How can we relate that carbon compounds are mostly covalent in nature? How can we say this? Okay. How can we explain that carbon compounds, because in this chapter we are going to study about carbon compounds. So how will you explain it that carbon compounds are going to be mostly in covalent as its basic nature? Why? See, carbon has the atomic number 6.
Is 2 4. What is the electronic configuration of carbon? It is because of 6 atomic number, its electronic configuration is going to be 2 4. Here 4 electrons are present in the valence shell. So when 4 electrons are present in the valence shell, it is not easier and compatible to gain or lose these 4 electrons. Rather, it will try to share these 4 electrons with the related atoms. Okay, so here carbon having 4 electrons in the valence shell try to share its 4 electrons with the other atoms, and when it shares its 4 electrons, it is forming covalent bond. Now you understand what is covalent bond. We will try to understand this with the help of an example. Okay, so here we are discussing covalent bond formation, students. First of all, we have discussed what is carbon and how it is existing in nature with so many number of compounds. Then first of all, you should know what is the atomic number and electronic configuration and what type of bond it is forming with the other type of atoms. Carbon forms covalent bond, and let us try to understand this concept of covalent bond with an example. Okay, so start the example here. Uh, can you cite any example for first ionic bond that you might have studied in your junior classes? What is an ionic bond? Ionic bond is a bond which is formed by the transference of electron from one atom to the another atom, from one atom to the another atom. So in the transference of electron, what one atom tries to do, it tries to complete its octet or duplet. It tries to complete its octet or duplet. Okay, in K shell it will try to attain the duplet, and in higher shells it will try to attain the octet. So in case of hydrogen it is duplet. Ionic bond, what is ionic bond? Which is formed by the transference of electron from one atom to the another, and it tries to complete the octet or duplet and try to attain the noble gas configuration. For example, if we say like NaCl, see in NaCl, sodium has 11 atomic number, 281 electronic configuration. In chlorine it is 17 atomic number, electronic configuration is 287. So what sodium will try to do to complete its octet? It will try to lose its outermost electron, and chlorine will try to gain this outermost electron. So they are basically transferring the electron from one atom to the another atom. Is it okay? Now you are getting the point that here sodium will attain the positive charge by losing one electron and attain the electronic configuration of 2,8, while chlorine will gain this one electron, attain the electronic configuration of 288 and attain the negative charge. This is called cation, and chlorine is attaining the negative charge, that is why it is called as anion. Sodium is called as cation, and chloride with negative ion is called as anion. And the bond which is formed between these positive and negative ions is called as electrovalent bond, because electrovalent bond is formed when positive and negative ions which can attract each other by electrovalent forces. So here are ionic forces existing between the positive and negative charges, and this will lead to the formation of electrovalent bond. Okay, now because we have already discussed the example of NaCl in the lower classes, here we are trying to discuss the covalent bond formation. What is covalent bond formation? In the covalent bond formation, as we are discussing here about carbon, so take the simplest example of carbon like CH4. In the example of CH4, carbon has atomic number 6. What is the atomic number of carbon? Carbon has atomic number 6. It has electronic configuration to 4. 4 electrons are present in the valence shell of carbon. Hydrogen has 1 electron, and here are 4 electrons present in each valence shell of hydrogen atom. Is it okay? So what will it try to do? In CH4 molecule, these 4 electrons can be shared by these 4 hydrogen atoms to complete their octet. Why carbon is doing such type of sharing? Because if it try to gain or lose these 4 electrons, it will require high amount of energy. So to avoid this high content of energy, high requirements of energy, it will try to share its 4 electrons to complete the octet with the 4 hydrogen atoms respectively to complete its octet. Are you getting the point? Everyone, students, are you getting this point that carbon has 4 electrons? How will it complete its octet? By sharing its valence electron with the valence electron of respective hydrogen atom. So here hydrogen will complete its 2 electron in the K shell and carbon will complete the octet in the higher shell. Is it okay? Is it okay with everyone? Are you getting how methane is formed? We have discussed the first example of carbon, the simplest one, in which carbon is forming 4 covalent bonds with hydrogen atom. So here what we are trying to say is covalent bonds are formed by the mutual contribution and sharing of electrons in the bonding atoms. How covalent bonds are formed? These are formed by mutual sharing of electrons, or here there is mutual contribution of electrons in the bonding atoms. It is called as bond pair of electron bonding pair. Okay, because this electron pair is participating in bond formation, that is why it is called as bonding pair or bond pair. Any electron pair which doesn't participate in bonding is called as lone pair. We will discuss the examples of the lone pair in uh, further examples. Okay, so here we are discussing about covalent bond formation. Now we will try to discuss here the covalent molecules in which the bonding atoms are same. This means if we take the homoatomic molecules. What are homoatomic molecules? What are homoatomic molecules? As the name is suggesting here, that the molecule which contains the same kind of atoms, the same kind of atoms are there, then the molecule is called as homoatomic molecule. For example, you might have heard about O2, N2, H2 molecules. They are diatomic molecules. Okay, how the bond formation is taking place here? How the bond formation is taking place here? Okay, how will you explain it? See here, oxygen has 6 electrons in its valence shell, because see here we are also writing the electron dot structure. So in the electron dot structure, what we write on the symbol of the element, we write only the valence electrons present on the respective element. For example, oxygen has electronic configuration 2,6. So we will only write 6 electrons on the symbol of oxygen element. Only 6 electrons should be represented here on the oxygen symbol. Is it okay? Is it okay with everyone? So here, yes, Parth Gupta, very good evening. We are going to discuss here carbonates compounds, the summary of carbonates compounds. Oxygen molecule formation. Here we are discussing the oxygen molecule formation with the help of electron dot structure or Lewis dot structure. How will you explain it? That on oxygen atom, if 6 electrons are present, because the valence electrons are 6, so in case of Lewis dot symbols, you have to represent only 6 electrons on the symbol of oxygen. Take another symbol, another element of oxygen, write the 6 electrons here also. Now complete the octet. Now oxygen in this case has 8 electron and completed its octet. In this case, this oxygen atom has also completed its octet by sharing these 2 electrons from the another oxygen atom. This is how the 2 oxygen atoms are forming 2 covalent bonds with each other. See here, if we represent this in the form of structural formula, how will you represent it? This is the electron dot structure. In electron dot structures are very important to draw here according to your class. Electron dot structure of O2 molecule. Okay. In structural formula, you represent just covalent bond formation between the atoms. So here two covalent bonds are formed. So what we are discussing here is about homoatomic molecules, the molecules which are formed by same kind of atoms. Here molecule is formed in which covalent bonds are there, but the kind of atoms that are forming the covalent bonds are same. Are you getting the point, students? Everyone is there. So here covalent bond formation between O2 molecule, this can be shown like in this format. Now if we compare the homoatomic molecules with the another term which is called as heteroatomic molecule, how will you explain it? Heteroatomic molecule. What are heteroatomic molecules? Heteroatomic molecules are those in which there are two or more than two different kinds of atoms participating in a molecule for the formation of covalent bond. Are you getting the point? What are heteroatomic molecules? In which the bonding atoms are different. Bonding atoms are different. Is it okay? Bonding atoms are different. As we have already discussed the example of methane molecule. This is the structural formula of methane molecule. How you have drawn the structure? Carbon has 6 atomic number with the electronic configuration of 2, 4. To draw the Lewis dot symbol or electron dot structure of methane molecule, you have to write 4 valence electrons on carbon. This is what we have written here, and this will form 4 covalent bonds with the respective hydrogen atoms like in methane molecule. Is it okay? Bonding atoms are different here, so this is a type of heteroatomic molecule. So here we have discussed the classification of molecules into two types, homoatomic and heteroatomic molecules, according to the kind of atoms that are participating in a molecule. Next we are going to discuss is are some examples of electron dot structure that are very important according to your syllabus. You must know how to draw the electron dot structure of some simple molecules we are going to discuss here. Okay. So let us study the first example like we are discussing here, water molecule H2O. How will you draw the structure of water molecule? Here we will discuss some another points related to water molecule structural formula and electron dot structure. So in this water molecule, there is the oxygen atom which has 8 atomic number, electronic configuration 266 are the valence electrons shown on a Lewis dot symbol. A Lewis symbol is a symbol of the element carrying valence electrons. So we are trying to draw here the Lewis dot structure of water molecule. How will you draw it? Here see what will happen. It has to complete the octet by sharing 2 electrons. So how will it complete these 2 electrons? See here, if we write the electrons on oxygen symbol in this way and 1 electron of hydrogen in this way, So we can easily show here that oxygen has completed the two electrons in the K shell. It is the inert shell configuration of helium. So hydrogen has completed its duplet and oxygen has completed its octet. Is it okay? If you are writing in this way, in which you have paired the electron, then it is not possible to show a covalent bond formation with the single electron of hydrogen. That is why I am showing you here that only one electron should be shown here, because one covalent bond formation is occurring with one hydrogen atom, another covalent bond is forming with another hydrogen atom. Two covalent bonds are formed. So here we are going to discuss a new term, that is, in spite of this bond pair, how much bond pairs are there? Two bond pairs are there, and the bond pair which does not participate in bonding is called as lone pair. This is the lone pair. Lone pair is the electron pair which does not participate in bonding. Which does not participate in bonding. Are you getting, students, what we are trying to discuss here? Electron pair which does not participate in bonding is called as lone pair. This is lone pair. How many lone pairs are there? Count them. Count them fast. How many lone pairs are there? There are two lone pairs. So here we come to know that in water two bond pairs are there and two lone pairs are there. So it is very easy to draw the electron dot structure of any molecule. Like simplest of the molecules we are discussing here according to your level, and we have discussed here homoatomic molecules and heteroatomic molecules. Okay, let us now discuss another point after heteroatomic molecule. It is as a result of electron sharing, the atoms acquire either 2 or 8 electrons in the shell. Is it okay? So, when an atom shares the electron with the another atom, so this is called as covalency. What is the term called as covalency? Covalency of an element may be defined as the number of electrons that an atom shares with the electron that an atom shares with the electron of electrons of other atom. In other words, to make it a little simpler, we can also say that number of covalent bonds are called as its covalency. What is covalency? Number of covalent bonds formed by an atom in a molecule is called as its covalency. See, in this example, we have taken so many examples. Can you tell me here that in water molecule, what is the covalency of oxygen here? How many number of covalent bonds it is forming with another atoms? So you will say that it is forming two covalent bonds. The covalency of this oxygen atom in water molecule will be 2. Is it okay? What is the covalency of hydrogen in water molecule? See, for one atom it is 1. So covalency, like if we say in oxygen molecule, the covalency of oxygen is 2. In nitrogen molecule, as it forms 3 bonds with each other, here the covalency is 3. In fluorine molecule, it forms one bond, a single covalent bond with each other. So the covalency of fluorine molecule is 1. So we can easily explain what is the number of covalency or what are the total number of shared pair of electrons between the two atoms with the help of covalency. Covalency is easily asked by the teachers in 1 marker questions. So it is an important for 1 marker questions. Next we are going to discuss here is students, different allotropic forms of carbon. Okay, what are the different allotropic forms of carbon? See here, what is the term we are taking here next is, what is allotropy? What is allotropy? See here, what is allotropy? Allotropy is the property of an element in which an element can exist in more than two forms. An element can exist in more than two forms. Are you getting the point, students? What is an allotropy? Allotropy is the phenomena exhibiting by an element in which it can exist in more than two forms. In which it can exist in more than two forms. So here, if we explain the property of allotropy of carbon, then we can say here that in allotropy mostly carbon element is existing in the form of both crystalline as well as amorphous nature. Crystalline as well as amorphous nature. Okay. You might be knowing what is crystalline and amorphous nature, a well-defined structure in which an element exists in 3 dimensions is called as crystalline structure, while the powder form in which the element is existing is known as its amorphous form of structure. In crystalline forms and amorphous forms, what are the two popular crystalline, like if you have been asked that what are the two popular crystalline varieties of carbon, okay, how will you explain it? See, diamond is the hardest crystalline form of carbon. Okay, diamond is the hardest crystalline form of carbon. Means diamond is the allotrope of carbon which is existing in a crystalline form, and it has a very unique structure. Diamond has a very unique structure. Here carbon is existing as bonding to 4 other carbon atoms by 4 covalent bond. It is a 3 dimensional network, and carbon carbon bond length is about 154 picometers. Okay, so the mostly why we study about diamond. Diamond is basically a bad conductor of electricity, since all the 4 valence electrons are involved here in the covalent bond formation. No free covalent bond is there. So if no free electron or bond is there in case of like diamond, it will become a bad conductor of electricity. It will become a bad conductor of electricity. Why? How will you explain it? Why diamond is a bad conductor of electricity? Because in diamond there is no free valency. Okay, no free electrons are present here. All the 4 covalent bonds are present in the bond formation. So because of the lack of free valency, there exists as a bad conductor of electricity. Let us discuss about some common uses of diamond here. Diamond, because of its hardness, as you know, it is a very hard non-metal allotropic form of carbon. So because of its hardness, it is used for cutting marble, granite, glass, okay, and as well as diamond. It is used as an abrasive for polishing hard surfaces, and a lot of important uses are there, like cutting of diamonds also. And cutting of diamonds also can be done with the help of diamond. Now we are discussing about the next allotrope of carbon, which is graphite. Graphite is another crystalline allotropic form of carbon and occurs free in a free state in nature. Okay, how can you explain the structure of graphite? Structure of graphite is very interesting, because we have discussed in diamond that carbon is occupied with all the four carbons with the help of four covalent bond. But in graphite, what is happening? In graphite, see here, in graphite, what is happening? There is a formation of hexagonal structure and a layer formation in a graphite structure. How it is possible? See, as we are drawing here, you might be understand that how we are drawing the structure of graphite here. In the structure of graphite, see, what is most important is there is a one free valency existing in graphite. Only three covalent bond formation is there by each carbon. Only three covalent bond formation is there. Every carbon is forming three covalent bonds and one valency is free. If valency is free, then free valency is responsible for good conductor of electricity. It will be good conductor of electricity, okay, because free valency is there, and this free valency is responsible for many other important properties of graphite, like it is used in lubricating parts of machines, because uh, graphite occurs in the form of layers. These layers are held together by weak forces of attraction, and like we have shown here with the help of dotted lines, these dotted lines are showing that three valencies are occupied for each carbon atom, and these uh, dotted lines represent here the weak forces of interaction between each layer of carbon atoms. If weak forces of attraction are there, so one layer can easily slide over another layer and it will act like an lubricant. It will act like an lubricant. Are you getting the point? Here we are discussing that why graphite shows the lubricacy, why it is used as a lubricant, okay, and this is the special property of graphite, because in graphite carbon layers existing in the form of layers can easily slide over each other because of the weak interactions between these two layers. Even the small pressure can make these slides uh, can make these layers slide over each other, okay. So here they are dull in nature, they have no metallic luster, they are very dull in nature, just opposite of diamond, and soft and greasy, and because of the free electrons, these are good conductor of electricity, and that is why because of this property of good conductor for electricity, graphite is used to make electrodes for the cells, in which the process of electrolysis can be carried out easily. Are you getting, students? What we are discussing here is electrolysis process can be easily done with the help of graphite rods. Okay, so the question that is mostly asked is that diamond does not act as a good conductor of electricity, because in diamond all the four valencies are occupied with the four respective carbon atoms in the formation of four covalent bonds, but in graphite only three valencies are actually forming the three covalent bonds, but the fourth valency is free here, which that is why it is acting as a good conductor of electricity and is used in the process of electrolysis. Okay, so graphite is relatively soft and greasy because its structure is not compact like that of diamond. So we are discussing here the differences between the properties of diamond and graphite, and because of these properties diamond has very high melting point, density is also very high for diamond, and diamond is transparent whereas graphite is opaque. Density of graphite is relatively lesser in comparison to diamond, and lower melting point in comparison to diamond because of the attractive forces that are participating here. Okay, now come to the next point here that we are going to discuss now is why carbon is known as such a versatile element. Why carbon is known to be such a versatile element? Because it is forming a number of covalent bonds in the nature. Why it is forming such a large number of covalent bonds, students? What is the reason behind it? Can you tell what is the reason behind it, why it is forming such a large number of organic compounds? So here comes the most important and basic concept that is we are going to discuss in this chapter in detail is the property of carbon that makes it a versatile in nature is its self-linking property or catenation. What is the property called? Catenation. Catenation is the self-linking property of an element with the same kind of element. Okay, self-linking property of carbon, which is carbon is showing in almost all its organic compounds. So catenation is self-linking property. It is maximum in carbon atom and is responsible for the existence of such a large variety of organic compounds existing around us. In its compounds, carbon is always tetravalent in nature. Okay, carbon is always, it is a universal truth, or you have to apply it to every organic compound, that carbon should exist in the tetravalent form, tetravalent in nature. This means carbon must have the valency of 4, neither less than 4 nor more than 4. It should have valency equal to 4. Okay, now we are going to discuss these tetravalent compounds of carbon in detail, organic compounds in detail. Now what are organic compounds? Carbon containing compounds are basically organic compounds, and it is divided into groups and families. When organic compounds are divided according to their families or like series or groups, these are called as homologous series. What we call them? Homologous series. what we call them? Homologous series. Okay, when organic compounds, we put a certain type of organic compounds in a separate class and call it family or series or homologous series. So what are homologous series? Homologous series is a kind of family in which the successive members differ by CH2 group or by 14 atomic mass unit, and in which they carry the same functional group. They carry the same functional group. The functional group should be same there. If we say, starting from hydrocarbons are the organic compounds which contain hydrogen and carbon, and hydrocarbons can be divided into three forms. What are they? They are alkanes, alkenes, and alkynes. Now, in alkanes, what will be the general formula for alkanes? It will be CnH2n plus 2. In alkenes, it will be CnH2n. In alkynes, it will be CnH2n minus 2. So, here are some general formulas related to these hydrocarbons respectively, like alkanes, alkenes, alkynes. In alkanes, all the single covalent bonds are there. Single covalent bonds are there. In alkenes, double bond is there. In alkynes, triple bond is there. So single bond is there. If single bond is there, only single covalent bonds are there, then we call it as alkene family. Let us take the simplest example of alkene family first. In alkene family, like we are taking the first example of methane. What is the methane formula? CH4. What is the formula of methane molecule? It is CH4. So here in CH4, there is one carbon atom and four hydrogen atoms. Okay, in methane molecule there is one carbon atom and four hydrogen atoms, with which it is forming the four covalent bonds. If we take the another example like ethane molecule, in ethane molecule, suppose we take another example, another member of the alkene family, it will be C2H6. What is the next member? It is C2H6. The first member is methane, the second member is ethane. Okay, what is the difference between methane and ethane molecule? The difference between methane and ethane molecule is the difference by CH2 group. Can you see it easily here? What is the difference between CH4 and C2H6? It is the difference of CH2 group. CH2 group, by they are differing by CH2 group or 14 atomic mass unit, and both the molecules are carrying the single covalent bonds there. Suppose we take the another family, another member in this family, which is here after ethane, we take it propane molecule. See here, methane, then ethane, then propane. What is the formula of propane? Here it is C3H8. Okay, and in C3H8 it is also differing by CH2 group. See here, CH4, C2H6, C3H8. The difference is by CH2 group. Now you can ask me that how you are making these formulas. Students, it is very simple to make the formulas. What you have to do, we have already discussed this general formula. Put the values here. In CnH2n plus 2, if we put the value of n equal to 1, then it will come out to be CH4, or it will be like ethane called as methane molecule. Methane is the IUPAC name of the compound. CH4 is the methane molecule, the IUPAC name of the compound. The structural formula will be like, in which we will show the four covalent bonds of carbon and hydrogen. If we take the value n equal to 1, the formula comes out to be CH4. Now suppose we are taking the value of n equal to 2, then the value will come out to be C2H6. Put the value 2 here. What will be the molecular formula of the next member in the family? C2H6. So it will be ethane molecule. How will you draw the structure of ethane molecule? See, we have to write the carbon carbon double bond, carbon carbon single bond, and complete all the valencies with the hydrogen atom to cross check if you have written your structure correctly or not. What you have to do, students, count the number of carbon and hydrogen atoms. If the carbon number atoms and hydrogen atoms match with the molecular formula, then you have written the correct structure. See here, count them. 2 carbon atoms and 6 hydrogen atoms. As you can see here, the number of carbon atoms and hydrogen atoms are matching here, and all are having single covalent bond. So it is the correct structural formula for ethane molecule. Similarly, you can draw the structure for propane molecule. Now what we were discussing here is the homologous series. Homologous series is a series in which the successive members like methane molecule and ethane molecule differ by CH2 group. They are differing here by CH2 group. So in these two molecules we have seen here the difference between CH2 group and all single covalent bonds are there. These are the two important characteristics of homologous series, means the same functional group and the difference by CH2 group. And this same you can go for propane molecule as well. Put the value n equal to 3, it will be C3H8, and the IUPAC name will be propane molecule. Propane molecule will carry the same structure as like ethane molecule, but in propane you have to draw the 3 carbon atoms respectively. Draw the chain of 3 carbon atoms there and complete all the valencies with the hydrogen atom. Cross check your answer with the molecular formula. Count the number of carbon atoms and hydrogen atoms. If they are matching with the molecular formula of the compound you have written, so the structure is correct. Have you gotten the point, students? What we are discussing here, everyone can draw the structure easily. So here we are discussing, students, about homologous series for alkane family. Okay, now we are going to discuss the next homologous series. What is the next homologous series? The next homologous family we are going to discuss here is simply the next family, alkene family. Alkene carries the general formula CnH2n. If value of n is 1, then the formula, see here, we in alkene family there is a formation of carbon carbon double bond. So the for the first member you must have minimum number of carbon atoms as 2. Okay, you cannot have n value of n equal to 1 here, because you have to form a double bond between 2 carbon atoms. So minimum number of carbon atoms should be here 2. So n value if taken as 2, then the molecular formula will become C2H4. What will become the molecular formula of ethene molecule? The number of carbon atoms here are 2. So the example we are taking here is of ethene molecule. In ethene molecule there are 2 number of carbon atoms. This ene word represents the double bond. Eth word represents here the n value of n is equal to 2. Have you gotten the point? Value of eth is n equal to 2 and ene stands for the double bond in the carbon structure. So draw the structural formula of this compound. How will you draw it? You will draw in this manner, showing double bond between two carbon atoms completing the valency with the hydrogen atom. So here we have written the structural formula of ethene molecule. Okay, so we have discussed here the first member of alkene family. It is very easy to write down the further successive members in the alkene series. Can you draw them? Draw the next member. If n is equal to 3, put the value of n is equal to 3 in the general formula CnH2n. It will be like C3H6. So how will you draw it? The structure of C3H6. Draw the 3 carbon atoms chain and you have to write one double bond in the structure. Complete all the valencies of carbon. It should not be more than or less than 4. So what you have to keep in mind is this carbon must be have a valency of 4, not more than 4, not less than 4. If carbon is having valency 4, you don't have to put the next valency here, next hydrogen atom here. That most of the students try to do the mistake. You don't have to do it, because what you have to keep in mind is a carbon nature of carbon is tetravalent. It should have the valency of 4, not less than 4, not more than 4. So this is the structure of propene molecule alkene series, in which value of n is equal to 3. Okay, so here we are discussing the homologous series of alkene family, students. Similarly, you can write down the structure here, draw the structural formula and match your structural formula. Count the number of hydrogen and carbon atoms with the molecular formula that you have written here. How you have written C3H6 when n is equal to 3. You have put that in the general formula. You got C3H6. You have drawn structural formula and you can also cross check it. Okay, so this is how we have written alkene family homologous series, in which the successive members differ here by CH2 group, and all the members in this family are carrying double bond, so it is an homologous series. Okay, next what we are discussing here, students, is the next important family, because this is the main concept in the chapter that should be taken with a number of examples. You don't have to do any mistake among the families to draw any structure. So we are taking a number of examples here. See, Alkyne family is the next family we are going to discuss here. It is like in the alkyne family, it will be the general formula CnH2n minus 2. In this structure, carbon is having triple bond with the another carbon atom. Okay, like we have discussed in above, that carbon is having double bond with another carbon atom in alkene family. Similarly, in the alkyne series, it is having triple bond with the another carbon atom, and general formula is CnH2n minus 2. If we are starting with the value of n equal to 2, then we come to the first member of alkyne series, which will be C2H2, and this will be drawn like in a manner in which carbon is forming triple bond with another carbon atom, and here the valency can be completed with the hydrogen atom. You don't have to write more than 4 valencies because carbon is tetravalent in nature. The name, IUPAC name for the compound will be ethine. Why ethine? Because eth stands for 2 carbon atom and ine stands for triple bond. Okay, so this is the structure of ethine molecule. The next structure we are going to discuss here is the next one. Okay, see, if you take n value equal to 3, then the molecular formula will be C3H. Put here C3H. Value of H will be 2 into 3, 6 minus 2, 4. Okay, C3H4. How will you draw the structure? How can you draw the structure? Okay, let us try to draw the structure. Here we are drawing the carbon chain of 3 carbon atoms. Triple bond is there because it is an alkyne family. Complete the valency of carbon with hydrogen atom. Cross check it with the molecular formula. This is the molecular formula of propyne member. Propyne, in propyne, prop stands for 3 carbon atom and ine stands for triple bond. So here in propyne molecule there is a triple bond completing all the valencies of carbon with hydrogen atom, and you can cross check your structural formula, match the number of carbon hydrogen atoms with the respective molecular formula of the compound. If they are matching, then you have written the correct structural formula of the compound. Are you getting the point, students? Are you getting the point? Can you draw the next structure? Try to draw the next structure. Yes, everyone can draw here. Take the example of n equal to 4 and write down the structure. Comment me and try to answer it whether you have written the correct structure or not. Okay. Next family we are going to discuss here is about the functional groups. Okay, before discussing about functional groups, let us discuss about writing about IUPAC names of the compounds. How can you write the IUPAC names of the compound? Okay, we have to discuss about the functional groups of the organic compound, but before discussing functional group, let us discuss about the IUPAC name of a compound. How can you write the IUPAC name of a compound? We will try to understand writing of IUPAC name with the help of an example. Like suppose if I have written here one example, if you can write here the IUPAC name of this compound. Try to write down the IUPAC name of the compound, those who know the rules related to it. Otherwise, I am writing here. Check your answer. Okay. See, while writing the IUPAC names, what rules you have to follow? First of all, you have to see here that prefix is a part of IUPAC name which appears in the beginning. Okay, so when we write the IUPAC name, uh, how will you write it? This is the group called IDO. Okay, this is the substituent group which is called as IDO group. So here the prefix which is written, first of all we will write here prefix, and it is IDO. What is IDO? It is the prefix that you have to write first in IUPAC name. Okay, then after writing prefix, what you have to write is the word root. What you will write? Word root. So how will you write the word root for this compound? In this compound, The number of carbon chain you can see here is equal to 2. How many number of carbon atoms are there in this compound? The chain of carbon compound is 2. Okay, so if we are having one carbon atom, then it is word root, it is having the word root meth. If you are having two carbon atom chain, then it is called as eth. 3, for 3 it is prop. For 4 carbon atom chain, word root goes as but, and likewise for 5 it goes as pent. For 6 it goes like hex. For 7 hept, and for 8 it is like oct. Similarly, non, dec, unidec. Okay, and for 9 it is non. For 10 it is dec. It is the uh, word root which is the number of carbon atoms in the organic compound. So the word root here will be 2 carbon atom chain, and you have to write here eth. What you have to write here? Eth. The next, after writing word root, what you have to write is primary suffix. What is primary suffix here? Okay, what is primary suffix here? Here, see, all the single covalent bonds are there. In the carbon chain, you have to see. You don't have to consider this double bond because this is the functional group. In the main carbon chain, there are only single covalent bonds. So it stands for Alkene family in. Okay, primary suffix should be given as ane, in. Now what you have to write after primary suffix is secondary suffix. Secondary suffix will be the name of the functional group that is carried in this organic compound. As we are going to discuss shortly the families of functional group, but in this topic here we are discussing the IUPAC names, the rules related for writing the IUPAC name of the compound. How can you write the IUPAC name of the compound? So first of all you have to write the prefix, then word root, then primary suffix, then secondary suffix, and secondary suffix goes with the name of the functional group, which is oic acid, because this is functional group of carboxylic acid, and from carboxylic acid we only take oic acid. So how the IUPAC name can be written here? How it can be written here? See, now if you have ido, what is the position of ido? What is the position of ido in this compound? It is number 2. It is carbon number 2. How can you say that it is carbon number 2? Because the functional group should be given the priority in the organic compound, and that is why we will start the counting or numbering from the carbon atom which is carrying the functional group. It is itself, carboxylic acid is itself carrying a carbon, so it will be counted in the main chain of carbon atoms, and it will be like 1 and 2 carbon atom is carrying ido. So how will you write the name here? It will be written like, specify the number here, 2 hyphen, what is the halogen? This is halogen family, and it is ido group. We will discuss all the names in detail here. What you have to see here is the uh, the rules which are should be taken here in consideration for writing the IUPAC name of the compound. Okay, so this will be like 2 and now write ethanoic acid. Combine them all. Ethanoic acid. What you have to take in mind here is you can't write the two vowels together in a word. See here, when you are combining the three words, the letter E and O are coming together. So you have to skip this E, okay, here, and what uh, you have to write here is ethanoic acid. This is how you can write an IUPAC name of the compound. This is the method you can write the IUPAC name of the compound. We will try to write a number of examples here. Okay, we will try to write down the different examples so that uh, you must be clear with the concept of IUPAC naming of an organic compound, because it is very important in organic chemistry to understand the nomenclature of organic compounds or naming of organic compounds with the help of IUPAC nomenclature. With the help of IUPAC nomenclature. So in IUPAC nomenclature, it is basically an international union of pure and applied chemistry that has given some rules to name an organic compound. Okay, and aliphatic or aromatic compounds are identified by these IUPAC names. So, we are taking some examples to understand the concept of IUPAC naming here. Suppose we are taking some examples like, uh, can you give the IUPAC name of this compound? Try to write down the IUPAC name of this compound. It is very easy, and everyone can write down the name. Try to write it down. What will be the IUPAC name of this compound? This is CH. Okay, try to write down the name of this IUPAC compound. Okay, so it will be uh, like, first rule that you have to keep in mind is take the longest possible chain in the organic compound. Take the longest possible chain in the organic compound. It will be like 1 2 3 4 5 carbon atom chain, so it is a 5 carbon atom chain. Okay, so you have to take pent for this organic compound, PENT, word root for this compound. But there is a double bond in this compound, and for this double bond in this compound you can do the counting from right side or from the left side. Okay, you can do the counting from the right side as well as from the left side. From which side you have to take the counting in account? From which side you have to consider the counting? You have to count from the side, you have to count from that side to which the functional group carries the lowest number. Like if you are counting from this side, then carbon having functional group is carrying minimum number of carbon atom. Minimum number, it should carry the minimum number. See, if you are numbering from the left side, then it will be having number 3. So what you have to do, rather giving it number 3, you have to give number 2 to this compound. Okay, this is the correct method of numbering a compound. So it will be like, what will be the IUPAC name of this compound? This will be pent2ene or pentene 2. Okay, so this is like one rule that you have to keep in mind. Select the longest chain and give the minimum possible number to the functional group present there. As we have already discussed about the hydrocarbon family, in which alkenes, alkynes and alkanes are there. In alkenes, alkynes and alkanes, you have to keep in mind the position of double bond or triple bond. Okay, and give it the correct method of numbering. So here we next discuss about our functional groups. How will you name the functional groups in the organic compound? How can you name the functional groups in an organic compound? First, we are taking here monohaloalkanes. We are taking here monohaloalkanes. Okay. In monohaloalkanes, the members of the family, as the name is suggesting, is formed by replacing one hydrogen atom with the halogen atom. Like in alkanes, where the general formula stands for CnH2n, here one hydrogen is replaced CnH2n minus 1. Okay, sorry, plus 1. Here one hydrogen is replaced by X, and here one X carries one halogen atom. One hydrogen is replaced by one halogen atom. So we are writing here the molecular formula of first compound monohaloalkane CH3Cl, in which one hydrogen of methane is replaced by chlorine atom. What will be the IUPAC name of this compound? This will be chloromethane. Second, C2H5Br. What will be the IUPAC name of this compound? Draw the structure of C2H5Br. Make a straight chain of 2 carbon atoms. Complete the valencies with hydrogen atom should be 5, and one valency should be completed with Br. Bromo group. What is this functional group? Bromo halo group. This is halogen group and called as bromo. So it will be like bromo ethane. It will be like bromoethane. Take another example, C3H7I. Here we are taking 3 carbon atom chain, complete all the valency with the hydrogen atom, and there will be one iodo halo group here. What will be the name of this compound? This will be here as iodopropane. To specify the position of iodo group, here you need to specify the number at which this functional group is present in carbon atom. So it will be like 1 iodopropane. Okay, start with the capital letter and all other letters will be small in the IUPAC name. First mention the position, separated with a hyphen. So here you can write how we have written monohaloalkanes. The next family we are discussing here is alkanols. What are alkanols? Alkanols are alcohols in which there is a functional group called alcohol. This is alcohol, the simplest of the member, in which one hydrogen of methane is replaced by OH, so it is called as methanol. If we take 2 carbon atom chain, it will be like C2H5OH and ethanol. Similarly, like we have drawn the structures of monohaloalkanes, you can draw the structures here too. Okay, it will be very easier to understand the structures if you are getting the one like monohaloalkanes. Now it is easier to draw the another functional group like alcohol family, in which we are discussing the third member of the family. The first member, in which there is one carbon atom, it is methanol, IUPAC name, and the second one is ethanol, IUPAC name ethanol. The third is C3H7OH, it will be propanol. What will be the name? Propanol. But if you draw the structure of propanol, similarly as you have written the structure here in iodopropane, the functional group OH can be at position 1 as well as 2. So there will be 2 structures possible for propanol. What will be they? They will be like propane separated by an hyphen 1 ol, and the next will be propane separated by hyphen 2 ol. And can you draw these two structures? Try to draw these two structures. These are called as isomers, position isomers. What are they called as? Position isomers. So you should be it should be known to you students that what is isomerism, what are isomers. Isomers are the compounds which are having the same molecular formula C3H7OH but different structural formula, because if we try to draw the structure of propane 1 ol, then it is having OH group at position number 1 and all the valencies of carbon are completed with the help of hydrogen atom. Similarly, see here we can also complete the valency with the hydrogen atom, but the number 2 is carrying OH group. Complete all the valencies of carbon with hydrogen atom. So it is propane 2 ol, it is propane 1 ol. Can you give the difference here? What is the difference between the two? The structure formula of the two structures are different here, but the molecular formula is same, and this is called as isomerism. Molecular formula is same. Molecular formula is same, but structural formula is different. Structural formula is different. Okay, and these are called as isomers. These are called as isomers. We will discuss the topic of isomerism in detail also in our further like in our further portions that we are going to discuss shortly. Next functional group which is we going to discuss is aldehydes. Aldehydes or alkanals. What are they? Alkanals, like alcohols, which have general chemical name alkanols. Next functional group what we are going to discuss here is aldehyde, and the IUPAC name goes like alka nulls. Al is used here to predict the functional group. It will be like RCH double bond O. R is the alkyl group here. Alkyl group may be like the like if we say the first member in aldehyde family, then because this family is having CHO group, and CHO group is also starting with carbon atom, it should be included in the main chain of carbon atom while counting. So if we put here hydrogen and write here the functional group, then it is having one carbon atom chain compound, and it will be called as, put the value of alkane as methane and then end it as al. Methanol will be the compound. What will be the compound? Methanol. Is it okay? Methanol will be the compound HCHO. Put the value n equal to 2, and in this family if you put the value n equal to 2 means you have to take the chain of two carbon atoms in which one is itself CHO and the other is alkyl, that is methyl group. So it will be like two carbon atom chain carrying CHO group, and this will be named as ethanol. It will be named as ethanol, ethane. Okay, from ethane. It is derived from ethane, and aldehyde functional group is there, so it will end as al. Next member, you can also try for the next member. Try to write it down. Try to write it down. The third member of aldehyde family. How will you write it? Try everyone. How will you write the structure of third member of aldehyde family? There will be three carbon atom chain in which the terminal position is carrying the functional group CHO. in which the terminal position is carrying CHO group and the other carbon atom is completing their valency with the help of hydrogen atom. You have to take care that carbon atom valency should not exceed more than or less than 4. It should be equal to 4 because carbon is tetravalent in nature. So what will be the structure of this compound? This will be C3H. Count the number of hydrogen atoms. C3H, number of hydrogen atoms will be H6O. Okay. So in this structure it is propane. You have to drop E here because E and E and E and A vowels can't go together. So you have to drop A here, write ul. Propanol, P starting as a capital letter and the IUPAC name of the compound will be propanol. Okay. So this is the aldehyde family. You can write how the aldehyde family can be written. So keep the fact in mind here that the functional groups that starts from carbon atom itself should be counted in the main chain of carbon atoms. You don't have to put the CHO group like if you have to write the structure of ethanols. What students try to do sometimes is ethanol they put a chain of 2 carbon atoms, and for aldehyde they put the CHO group and write the valency, complete the valency with the hydrogen atom. Is it a correct structure? No, it is not the correct structure. You can't write like this because CHO itself starts from carbon atom. You cannot add it after 2. It should be included in the 2 carbon atom change. So the structure would be like this. Okay. So don't do this kind of mistake in which first you are writing 2 carbon atom and then adding CHO to it. No, you can't do it like this because the functional group starts from carbon atoms. They are included in the main chain itself. Okay. So this is aldehyde family of functional group. Next we are going to discuss is a very interesting like aldehyde family. It is the ketone family. Okay, ketone family, and it is having in the ketone family the general naming goes like alkanone, and in alkanones there is functional group C double bond O, and the both sides they are carrying either R might be equal to R or R might not be equal to R. Okay, it would be equal to R dash. So we will take both the examples here. Like if we are taking the example of CH3COCH3, see here, this is a carbon chain. Select the longest chain first. This is the longest chain of 3 carbon atoms, so it will be like propane. Okay, it will be propane, and you have to drop the E here and add on to it, so it will be like propanone. It would be like propanone. Okay, so in propanone there will be a chain of 3 carbon atoms in which the center carbon atom is carrying this keto group and its naming will be like propanone. If you are making a chain of 4 carbon atoms in which the second carbon atom is carrying the functional group keto group or ketone group and complete all the valencies of other hydrogen other carbon atoms with hydrogen. Okay, so in this structure don't put the hydrogen atom here, don't put the mistake here, okay? Don't do this mistake, because keep it in mind that carbon is tetravalent in nature. Its valency should be equal to 4, okay? Now what we are seeing, see, here there is a methyl group on one side of keto group, and there is ethyl, so R is not equal to R on C double bond O. In this case R is equal to R dash, okay? So here R might not be equal to R, or it can be equal to R. So in this case, what we are going to discuss is the family of ketone, and ketone family can be named as alkanone families, okay? So in this family it is named as alkanone. The two alkyl groups can be same, the two alkyl groups can't be same, both possibilities can be possible. And next group we are going to discuss here is alkanoic acid or carboxylic acids. What are alkanoic acids or carboxylic acids? Okay, in these compounds, the first thing you have to keep in mind is the functional group they are carrying are COOH. COH is the carboxylic acid group with an alkyl group. Here see the first member, because the functional group is itself starting from carbon atom, so we have to consider it in the main chain of carbon atoms. Huh? Uh, Listen, here we are taking the first example of alkanoic acids. The first example will be methanoic acid. What will be the first example? It will be methanoic acid. Okay. Alkanoic acid, because the carbon chain is of one carbon atom. So put the alkane methane here, drop E from here, because E and O, both the vowels can't go together, and add oic acid, and this is how we have gotten the Iupac name of first member of our carboxylic acid family. Okay, next what we are going to discuss here is CH3COH, ethanoic acid. This is ethanoic acid. Try to draw the structure of ethanoic acid. See, the structure of methanoic acid will be like this, in which carbon is carrying a double bond with one oxygen atom and single bond with another oxygen atom. Now what you have to draw here, carbon chain of two carbon atoms, in which this carbon atom is carrying the functional group carboxylic acid, complete the valency of another carbon atom with hydrogen atom, because the compound is carrying a chain of two carbon atoms. So it will be like ethane, drop the E latter here and add oic acid, because E and O, both the vowels can't go together, so drop the vowel E, and here we are getting the second member of alkanoic acids. Okay, the next member, what will be the structure of the next member of the family? Similarly, you can write down the next structure, C2H5COH. Write down the next structure, write down the structure formula here, and suggest me the name. Please suggest me the name. Okay, what will be the name of this compound? Anup Roy ji, hello, how are you? And we are here discussing carbon compounds from class 10, the chapter, full chapter in detail. Here we are discussing the functional group, the families of functional group. The last we have discussed is alkanoic acids or carboxylic acids. How can you name it? How can you name the IUPAC naming of alkanoic acids. Now we are taking some aliphatic organic compounds. What are aliphatic organic compounds? See, organic compounds can basically be divided into two parts, aliphatic as well as aromatic organic compounds. So aliphatic organic compounds are basically the straight chain of carbon atoms. Okay, in the aliphatic organic compound there is a straight chain of carbon atoms. Okay, but aliphatic carbon atoms can further be divided into many parts. Organic compounds can be divided into aliphatic and aromatic compounds. Okay, and here aliphatic compounds are basically open chain compounds. Open chain compounds. Now organic compounds we are discussing here, and as we are discussing the open chain, organic compounds can also be divided into closed chain or cyclic compounds. Cyclic compounds. Okay, organic compounds can be divided into open chain as well as cyclic compounds, open chain as well as cyclic, and the classification can also be done like aliphatic and aromatic compounds. Okay, now open chain and closed chain, how can you divide them? Closed chain can further be divided into three types like alicyclic, aromatic and heterocyclic. As we have already discussed about all the types of organic compound classification in our videos, you can get the link in the description box. Okay, in organic compound classification, organic compounds can be divided like aliphatic and aromatic. It can also be divided like open chain and closed chain. Closed chain cyclic compounds can be further divided into alicyclic, aromatic and heterocyclic compounds. Take the example of each category. In the open chain compounds we are taking the examples of like alkane family. Suppose we are taking the example of propane, open chain aliphatic compound. Okay, in the closed chain cyclic compound, take the example of alicyclic compound. This is alicyclic compound cyclopropane. What is this compound? The corners represent here carbon and completing valencies of each carbon with hydrogen atoms, so it must be having CH2 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 bonding, so it can be represented in a triangular form. Okay, this is bond line representation. It can be represented in the condensed formula, bond line representation, or in the form of structural formula where you can show it with the help of covalent bonds. In the covalent bond diagram you can show it like all the four covalent bonds of carbon can be shown here. So this is the structural formula, this is the condensed formula in which you are not representing the bonds between carbon and hydrogen, and this is the bond line representation of alicyclic compounds. Aromatic. What are aromatic compounds? Okay, aromatic compounds are those cyclic compounds which contain in them one or more hexagonal rings of carbon atom, and there will be alternate double bond in the structure. So it is the bond line representation of benzene. It is the bond line representation of benzene, or it can be represented in the condensed formula like CH double bond CH. See, all the corners here are carbon atom. Represent the double bond So it will be like carbon carbon double bond, leave a gap, then add carbon carbon double bond, okay, again single bond, again double bond, and complete the alternate single and double bonds in there, single and double bonds are there, and complete all the valencies with the hydrogen atom. So here the structure of benzene is bond line representation. This is condensed formula, and if you are representing the bond between carbon and hydrogen also, then it will be the structural formula of the aromatic compound. So what is the necessary condition for a compound to be aromatic in nature? That it should have at least one hexagonal ring in the structure. One hexagonal ring in the structure should be there, and alternate double bonds should be there. So it will be an aromatic molecule. This is known as benzene ring. It is also known as benzene ring. It can be represented as a benzene ring. Okay, so these are aromatic compounds, and you can take some another example, like if you are taking methyl group on benzene as a substituent, then it is known as toluene. What is known as this is known as toluene. The organic compound is known as toluene. Suppose on benzene, if you are having C2H5, then it is known as ethyl benzene. If you are having OH group on benzene, then you can call it phenol. And if you are having NH2 group on benzene, then you can call it aniline. So these are aromatic compounds basically. Okay, in alicyclic or cyclic compounds, there can be unsaturation also, like this is a saturated alicyclic compound in which all the bonds which are formed are single covalent bonds. Suppose there is in this structure there is a double bond. Okay, this is a structure in which there is a double bond. So this will be the condensed formula for cyclopropene molecule. Cyclic compound which is unsaturated, the IUPAC name of this compound will be cyclopropene. Okay, if you are writing like this is cyclobutane, cyclic, as well as 4 carbon atoms, so it will be cyclobutane. If you write one double bond here and make it unsaturated, so it will be cyclobutene. So these are alicyclic compounds which are unsaturated, You can similarly write the bond line structures, condensed formula and structural formula for these compounds also. Okay, the next classification that we can consider here are heterocyclic compounds. Heterocyclic compounds are those in which both alicyclic as well as see, in both alicyclic and aromatic compounds are having ring of carbon atoms only, but in heterocyclic there is an introduction of atom other than carbon atom. Okay, like if we draw this structure, see here the example of heterocyclic compound. See the example. What is the example here? In this example, we are drawing the chain of carbon atom, as well as we are introducing a new atom like nitrogen in this molecule. Okay, and this is called as pyrrole. What is the name of IUPAC name of this heterocyclic compound? This is pyrrole molecule. In this pyrrole molecule, it is heterocyclic because there is a chain of carbon atom in which there is besides carbon atom there is another atom also, that is why we are calling it as heteroatoms. Heteroatoms may be present there, like there may be oxygen or there may be sulfur. If suppose we are writing here oxygen, then it is called as furan. If we are writing here sulfur, then we call it as thiophene. Okay, so this is basically the classification of organic compounds that can be done on the basis of how the chain is there, close or open, or how aliphatic or aromatic compounds can be classified. And it is very important, keep it in mind, how can we classify it with different examples, as we have already discussed here the different examples. Okay, so we have gone through a number of families, a number of examples, different types of practice exercises to understand the topic of classification for organic compounds, the nomenclature of organic compounds on the basis of different functional groups, all we have discussed. Okay, and further you can get the different types of videos, practice exercises in the description box also. Next we are discussing here are the chemical properties of carbon compounds. The chemical properties of carbon compounds, we are taking a little bit faster, and in a nutshell we are taking the topic not in detail here. So basically we are dealing here about the chemical reactions that are shown by carbon compounds. What are they? The first chemical reaction that is shown by carbon compound is combustion reaction. Combustion is a reaction in which the organic compound, we are taking the example of methane. Methane gas, when we burn it in the presence of oxygen, not in air, keep it in mind, we are taking here the ample of oxygen, not air. Okay, okay, no, so here when we are doing combustion, then carbon dioxide and water is produced with an enormous amount of heat, and light is also evolving out here, making it an exothermic reaction in which high amount of heat is produced in the reaction. Balance the reaction, balance the equation carefully. How will you balance it? Okay, how will you balance the equation? See, the number of carbon atoms are balanced on both the sides. The number of hydrogen atoms in methane are 2, but in opposite right hand side in water molecule there are 2 hydrogen atoms. Multiply it with 2, so the number of hydrogen atom here becomes 4. Okay, now count the number of oxygen atoms. In this side the total number of oxygen atoms are 4, and on the left side there is 2. You have to multiply the number with 2 to get the 4 oxygen atom to make this equation balanced. Okay, try to write down this equation also. Ethane, combustion of ethane, how will you write it down? How will you write it? Write it down now. With the enormous amount of heat and light produced in the reaction, so it is also called as exothermic reaction. Students, balance the equation. How will you balance it? See, the number of carbon atoms on the left hand side are 2, so balance the here with multiplying 2 on the right hand side. Number of hydrogen atoms are 6 on left hand side, multiply it with 3, so we are getting here 6 hydrogen atoms. Count the number of oxygen atoms on both the sides, as the number of hydrogen atoms on right hand side are 5. 4 plus 3, 7 hydrogen atoms are there. How can you make this 2 oxygen atom equal to 7? How can you make equal to 7? Okay, how can you do this? By multiplying it with 7 by 2. Multiply it with 7 by 2. Are you getting the point? If you multiply 7 by 2 with 2, 2 will be cancelled with 2 and 7 will be left out. 7 on both of the sides will make the equation balanced. Okay. Similarly, you can do the combustion reaction for ethene molecule, ethyne, butane, benzene, ethyl alcohol, and for any hydrocarbon that has been given to you for the combustion reaction. Further, you should know in this topic of combustion is that here when we are talking about combustion, so what we should know that our basic cooking fuel, which is LPG in our homes, what we call it as liquefied petroleum gas, what we call it as liquefied petroleum gas. Okay. So in this liquefied petroleum gas, if we see sometimes, we see the flame coming out from the burner is yellow and sooty. Why the flame comes out to be yellow and sooty in color, not in blue in color? Because the unburnt particle of carbon accumulates around the flame, okay, giving it a yellow or sooty flame. And there is incomplete combustion of fuel. There is an incomplete combustion of fuel. If incomplete combustion of fuel is there, then the fuel will not burn properly. It will produce sooty and black flame and yellow in color. If it is burning properly, it means if there is a complete combustion of the fuel, like LPG in your cooking cylinders, in the burner complete combustion is there, then the burner will burn with a blue flame. So this is how the sometimes a question comes out like in this manner, why there is a blue flame coming out from the burner, why it is turning out to be yellow flame or sooty flame. So you have to answer your question in terms of combustion. If there is an incomplete combustion, then there will be yellow or sooty flame. If there is complete combustion of the flame, then there will be blue flame. Okay. So this can be asked in your exam, students. This should be answered like in combustion, in incomplete or complete combustion. Okay. The next thing is LPG is a very clean fuel. Okay, like LPG, CNG, these are very clean fuels. They don't produce any waste products, side products, and they are not causing any pollution. Like coal and petroleum, they are containing the elements like nitrogen and sulfur, and when we burn these elements like compounds, coal and petroleum, they produce what they produce, nitrogen oxides that are very harmful, or sulfur dioxide or sulfur trioxide, sulfur oxides, nitrogen oxides, and these are highly poisonous, which leads to the pollution problems. Okay. So this is not useful for the environment to burn coal and petroleum. And we can see here why we are using LPG and CNG with the with like recent times, it has, why it has become so popular. Okay. Next we are going to discuss here is how are coal and petroleum formed. See, coal and petroleum are formed from when they have been decayed from under the earth from millions of years ago. They have perished millions of years ago. And with the high temperature prevailing inside, the slow combustion is turning them into coal. Okay. Petroleum, like petroleum also, it has resulted from fossil fuels such as marine creatures which died millions of years ago. And this is how coal and petroleum formed. The next we are going to discuss here, student, is a very important reaction after combustion reaction is addition reaction. Addition reaction is shown by the compounds which are unsaturated in nature. Okay, unsaturated compounds are like alkenes and alkynes, and which have general formula CnH2. And if we take the example of alkene, so see in this alkene series, if we take the example like alkyne CnH2n minus 2, a very common example of hydrogenation. Addition reactions, in addition reactions, a very common example has been taken as hydrogenation. What is hydrogenation? Is addition of hydrogen. Suppose we are taking the example of ethyne, and in ethyne molecule, if we are adding hydrogen, 2 moles of hydrogen, 1 mole of hydrogen, basically 1 mole of hydrogen when added up in ethyne molecule, it converts it into ethene molecule, and second hydrogen mole when combined in ethene molecule, it converts into ethane molecule. Are you getting the point? Are you getting the point? See here, in the presence of nickel catalyst, in the presence of 473 Kelvin, it will be converted in a saturated compound which is ethane molecule. And suppose we are taking the example of ethene molecule here. There is a double bond. You have to take 1 mole of hydrogen only in the presence of nickel catalyst. There will be at 473 Kelvin, it will be converted into ethane which has double bond. It is converted into saturated compound. It is converted into saturated compound. Okay, so unsaturated compounds can be converted into saturated compounds by catalytic hydrogenation. This is called catalytic hydrogenation, and it has a very practical significance, practical application also for the conversion of like vegetable oils which have unsaturation double bond present in them into fats. It has a very common application around us. Okay, so we can relate this example hydrogenation. Are you getting what is hydrogenation? Hydrogenation is basically the addition of hydrogen. Okay, so hydrogenation of oils can also be done, in which the edible oils can be hydrogenated in the presence of catalyst to form fats which are saturated. Okay, so these are some examples of addition reactions. And if in addition to hydrogenation of oils to fats, we can also consider some very important examples for your competitive exams that can be asked in your practicals in the lab test that can be asked. Okay, so let us take some examples of addition reactions. uh, like if we are taking the example of ethyne molecule, as it is having triple bond, and when we are adding here bromine molecules, two bromine molecule in one triple bond, it will be converted. See here are two bromine, sorry, 2 into 2 4 bromine atoms, so it should be added like in this manner, in which 4 bromine atoms are forming the 4 covalent bonds here and are converting it into a saturated compound. What will be the IUPAC name of this compound? This will be 1122 tetrabromo tetrabromoethane. Okay, so it will be 1122 tetrabromoethane molecule. Are you getting the compound? Have you gotten the IUPAC name of the compound? So here the unsaturation of a compound can be removed by adding a halogen molecule. Okay, we are taking bromination, example of bromination, in which addition of bromine can be done to the unsaturated compound to form a saturated organic compound. Okay, let us take another example, like suppose if you are taking molecule of ethene. In this example, of ethene, you have to add just 1 mole of bromine molecule, because there is one double bond here. So when you add this molecule, as bromine is yellow in color, okay, and when you add up this bromine in this ethene molecule, then what will it form? It will, see here, it will be converted into a saturated compound. This is called 1,2-dibromo, 1,2-dibromoethane, 1,2-dibromoethane, and it will be colorless compound. This is how you can test this unsaturated ethene compound. See here, we have also done the test for unsaturation, lab test for unsaturation. If you pass bromine gas through ethene, then the color or yellow color will get disappeared. So this is the test for unsaturation in a compound. You can test for unsaturation in the compound. If there is a double bond, then bromine molecule which is having a bromine gas, sorry, if you are passing through it bromine gas, then the color, yellow color, will get disappeared, it will change into colorless. Okay, and if we take some more examples, go a little deeper in the topic, then polymerization reactions can also be the example of addition reaction. Like if you take the example of ethene, take the n molecules of ethene, do it polymerization, do the polymerization of this ethene molecule. Polymerization means you are adding the n number of ethene molecules to form a long chain of polymer. Monomers are added up in a long chain to form a long chain of polymer. This is monomer, and you add up n monomers to get a long chain of polymer. Double bond is converted here into single bond. N number of this long chain of polymer is formed. Okay, so this is like if you are taking the example of ethene, then polythene is formed. Polythene is formed. From ethene, polythene is formed. Similarly, you can get propene. From propene, you can get polypropylene. You can get PVC polymers, sterylene, nylon 6 polymers, which are condensation polymers in water molecules are removed. Nylon 6 sorry, condensation polymer in which water molecule is removed, nylon 6. Okay, so synthetic rubbers can be formed. Polymerization, by polymerization reactions, these monomers can be converted into long chain polymers. Another type of reaction we are going to discuss here is substitution reaction. Substitution reactions are shown by the saturated compound. This means that we are considering here alkane family. Alkane family in which one hydrogen atom can be easily replaced by the halogen atom. So here we are making chloromethane from ethane in the presence of sunlight, which is represented here by H nu. Okay, methane, in methane one hydrogen atom is substituted with chlorine atom, and we are getting here chloromethane. In the similar manner, you can also see here, like if we are considering the substitution reaction in which further hydrogen atoms can be substituted easily. First here this one hydrogen atom can be substituted, then again, if you are adding here chlorine molecule in the presence of sunlight, then another hydrogen atom can be replaced. One Cl is there, one hydrogen is there, so HCl will be removed, hydrogen is replaced by chlorine atom, and here it is formed as dichloromethane. From chloromethane to dichloromethane it has formed. Okay, all the hydrogen atoms can be subsequently replaced in the form of tetrachloromethane. To get tetrachloromethane, where you have replaced all the hydrogen atoms with the halogen atom. Okay, so here all the halogen atoms are there by replacing hydrogen atoms. So what we are discussing here is the difference between saturated and unsaturated compounds. Uh, how can you differentiate between saturated and unsaturated compounds? How can you differentiate? As you have already discussed here, the first difference is saturated having all the single covalent bonds, but if there is a double bond in the structure or triple bond in the structure, it is called as unsaturated. Okay, the second difference is saturated compounds are showing substitution reaction, while this unsaturated compounds are showing addition reactions. This is an important point to be kept in mind, students. Keep it in mind. Saturated compounds are showing substitution reactions only. Substitution reactions only they are showing. They are not showing addition reactions. Addition reactions are only shown when there is a double or triple bond in the structure. Okay, and saturated compounds also do not discharge any color, yellow color with bromine water or with alkaline KMNO4. They don't discharge any color, but unsaturated compounds usually discharge the color. They make the color to colorless. Okay, discharge the color of both these reagents, bromine water, or you can take the example of alkaline KMNO4, which is a very strong oxidizing agent. Bromine water or with alkaline KMNO4, which is pink in color, they both show addition reactions, but substitution reactions, they are showing they are saturated compounds and they are having all single bonds. They don't discharge the yellow or pink color with bromine or alkaline KMNO4 respectively. Okay, and as all of us know that saturated compounds are called as alkanes and unsaturated compounds may be alkenes or alkynes. Okay, so this is the main difference between saturated compound and unsaturated compound. Now we are going to discuss some important organic compounds, students. Some important organic compounds which are related with the topic of carbon and its compounds. Okay, so here what we are going to discuss is some important organic compounds like ethanol, which is discussed in carbon compounds for your awareness about this compound. In this ethanol compound, what you have to study is basically the chemical preparation, manufacturing of ethyl alcohol. This can be done with the help of fermentation. For example, if you do the fermentation of sucrose with the help of invertase enzyme, okay, with the help of invertase enzyme, then it will be converted into glucose C6H12O6 with an isomeric form fructose having same molecular formula. Okay, so this is sucrose. With the help of invertase enzyme, it is converted into glucose as well as isomeric form fructose, both are isomeric forms. And glucose or fructose, you can take any example, this C6H12O6 with the help of zymase enzyme can be converted into C2H5OH with the evolution of carbon dioxide gas. Okay, so this is how alcohol can be formed by the process of alcoholic fermentation. We are doing the process of fermentation here. What are the necessary conditions you have to keep in mind for doing the fermentation? The temperature must be kept at 303 Kelvin or 30 degrees Celsius, students, as the higher temperature will kill the enzymes, because we are doing in a biological manner, so we have to take the temperature in consideration, should not be exceed more than 30 degrees Celsius. Either then these enzymes will be killed. Okay, and the next point you have to keep in mind is the concentration of sucrose that is taken here. The sucrose, the sugar concentration should be taken as not more than 10% m by m. This means that if you are taking 10 ml of sugar in 100 ml of solution, it should not be exceed more than 10%. Okay, and the process must be carried out in dark conditions. Light should not be there. Fermentation should be carried out in dark conditions in the absence of light, and air should also be not present there. Air should be absent there. Okay, absence of air should be there. If you provide these conditions for the process of fermentation, the ethyl alcohol will be manufactured. Okay, and the next process by which you can manufacture ethylene. Okay, from ethylene you can manufacture ethyl alcohol is like, suppose if you are taking ethene molecule and adding water molecule to it in the presence of H2SO4. In the presence of H2SO4, here water will add up. Water existing as H positive OH negative will add either side of double bond, H positive on one side, OH negative on either the opposite side, and it will be formed like CH3CH2OH ethyl alcohol. It is formed as ethyl alcohol. Ethene molecule is converted into ethyl alcohol or ethanol. Are you getting the point, students? We have done the two manufacturing by the process of fermentation and by the process of hydration of ethylene molecule. Okay, so these are the two basic methods for the preparation of ethanol. The physical and chemical properties you have to keep in mind are physical properties. Ethanol is basically a colorless liquid with a characteristic smell, and its boiling temperature is 78 degrees Celsius. But keep it in mind, students, physical properties you have to keep in mind is the first point, that it is neutral towards litmus. It doesn't show any reaction towards litmus paper. Okay, so this can be used, this property can be used as a point of differentiation with acids, okay, or with other functional groups. And ethanol is highly soluble, highly miscible with water. It is miscible with water. So these are the physical properties that you are discussing here. And if in the chemical properties you discuss the basically the combustion reaction, chemical reaction, what they follow. The combustion reaction, combustion is same as we can discuss here, like C2H5OH. When combustion is done here, it produces carbon dioxide and water. And ethanol is highly volatile and combustible liquid. Okay, so when we are burning it, it burns and catches fire very easily, immediately burns with a blue flame. Balance the equation, students, please balance the equation. Here two carbon atoms are there on the left side, so balance it with multiplying it with 2 on the right hand side, and see here the total number of hydrogen atoms on the left hand side are 6, so balance the hydrogen atom on the right hand side with multiplying it with 3, and now count the total number of oxygen atoms on the right hand side. The total number of oxygen atom, count them, 7, so multiply here with C3, total 6 plus 7, both sides are balanced in terms of carbon, hydrogen and oxygen. The complete equation is balanced here. Okay, the next important chemical equation is with sodium metal. When ethanol is made to react with sodium metal, it replaces here, the substitution reaction goes here, in which the C2H5ONa, sodium ethoxide, is formed with the evolution of hydrogen gas. See here, the simple substitution reaction is going here. You have to take sodium in the dry state and ethanol with when you are reacting it, it forms sodium ethoxide and hydrogen gas is liberated here. Okay, this is here you can be asked for testing hydrogen gas. How can you test hydrogen gas? For you can test it as we have already discussed on the channel, students. Whenever you have been asked to test for hydrogen gas, then you can take the burning mastic at the top of the at the mouth of the test tube, when it burns with the pop sound, that it indicates the presence of hydrogen gas coming out of the test tube. Okay, so not only sodium, you can also take potassium here, it will react in the same manner. And the next reaction is oxidation reaction. Oxidation in which there is an addition of oxygen, there is will be the addition of oxygen here. Okay, oxygen in the atomic form. How can you show it? See, suppose if you are as we are discussing here the example of ethanol, so when you are adding oxygen, nascent oxygen with ethanol, and this oxygen, nascent or atomic oxygen, has come from the strong oxidizing agents like KMNO4, alkaline KMNO4, which is also called as Bayer's reagent, or ethanoic acid, and then ethanoic acid is formed. Okay, simply you have to add up this oxygen in ethanol, and ethanoic acid is formed here. So this is the oxidation reaction shown when there is complete oxidation. So when complete oxidation is there, then 2 moles of nascent oxygen is added up. When only 1 mole of oxygen is added up in ethanol, then there will be the formation of aldehyde CH3CHO. There will be the formation of ethanol, and when you add up again nascent oxygen in it, then further it will form acetic acid 2 moles. This means 2 moles of nascent oxygen will convert ethanol into ethanoic acid. If you are adding 1 mole, then it will give ethanol. If you are adding further 1 mole of nascent oxygen, then it will give ethanoic acid. Okay, so in this manner, partial oxidation, which is this aldehyde formation, or complete oxidation in which acetic acid is formed, can be done. Okay, the next reaction is very important among this compound ethanol, which is called as dehydration reaction, students. What is dehydration reaction? See, in dehydration reaction, what happens? Uh, Basically, dehydration is called as removal of water molecule. So when you take ethanol molecule and react with conc H2SO4, concentrated H2SO4 in the presence of 443 Kelvin, then alkene is formed there. There is a removal of water molecule. Removal of water molecule is known as dehydration, an important reaction shown by alcohol family. Okay, so the next topic what we are going to discuss here is the test for ethanols. You can do the test with the help of sodium metal or with ester formation. These are the two tests you can do for if you are asked to perform the test for alcohols. How can you do the lab test for alcohols? So very important question for your exams. Here you can test for alcohols in two way. First is sodium metal test. How can you do the sodium metal test? Sodium metal test can be done in the same way in which when you are adding sodium metal in the dry state to ethanol, it is converted into sodium ethoxide with the evolution of hydrogen gas. And the second test is ester formation. What is ester formation? See here we have as we have not discussed this family, let us discuss it here only. Like alcohols, when they are allowed to react with carboxylic acids, suppose we are taking here the example of acetic acid, then how they react in the presence of acidic conditions, how they react, students. See here, there is a removal of water molecule. There is a removal of water molecules. How water molecule is removed? H positive OH negative is removed here, and the positive and negative radicals will combine in such a way that there will be the formation of ester. See here, we have removed the positive and negative part, H positive and OH negative, in the form of water, and then positive and negative ions attach itself to form a compound called ester. Ester formation is there. The group, alkyl group, which is linked directly to oxygen atom, is called as ethyl. How will you name it? Started from capital letter ethyl, and the rest is called as alkanoate. Put the ethyl word there, it will be like ethanoate. What we have done? Alkyl alkanoate is the general naming of esters. We have put the alkyl. In alkyl there is ethyl, which is directly linked to oxygen atom. The rest one is alkanoate, alkane. There are two carbon atoms, so put the word eth there. Okay, so there will be ethyl ethanoate formation, ester formation is there. They are pleasant smelling compounds which are formed here, and that is why we can test here easily as a lab test, and it is asked most often times. Okay, let us discuss some advantages and disadvantages of using alcohols in society, students. Obviously there are lots of disadvantages, as all of us know. This is habitual habit forming alcoholic beverage, and when it is consumed in a large amount, it is very, it can be very lethal also. Okay, and particularly it brings lowering of social level in the society. But if we consider it in terms of Advantages of alcohol. Then what will be the advantages of alcohol? It is a very good solvent, students. Alcohol is a very good solvent in organic compounds, for dissolving organic compounds. Very large number of organic compounds can be dissolved in ethanol very easily. Okay. Here we are discussing the advantages of ethanol. It is a very good solvent, and hence a very large number of organic compounds can be manufactured, like ether, chloroform, acetic acid, acetaldehyde. So large number of in large number of factories and industries this compound is used, and it is used for solving in paints, liquors, varnishes, cosmetics, perfumes also, and also in stoves, in spirit lamps, in labs for testing. Okay, for sterilization of skin also. And ethanol is also mixed with petrol in some proportion, students. You might be knowing this. Okay, it really undergoes to form carbon dioxide in water without causing any pollution problem. And this is the like important uses of ethanol. And to avoid the consumption of alcohol as a beverage, what we do the denaturation of alcohol. Denaturation of alcohol, ethanol, is done why the denaturation of alcohol is done. Because to avoid the consumption of alcohol, methanol is added. Its nature is spoiled there, or sometimes copper sulfate is added to spoil the nature or denature the alcohol, uh, which is ethanol. Okay. To understand the concept of denaturation of alcohol, it is done in order to avoid the consumption of ethyl alcohol, and should be used in the right manner for commercial purposes in industries or factories, for the manufacturing of different organic compounds, rather its consumption as a beverage. um, Thank you, dear Parth, for your compliment. Okay, I hope you are understanding the topic well. Next, we are discussing here, students, our next organic compound, which is ethanoic acid. Ethanoic acid is also a very important organic compound. In ethanoic acid, it is CH3COOH. This organic compound can be easily manufactured from ethyl alcohol by the addition of oxygen with the help of enzyme called acetobacter. Okay, acetobacter can easily convert ethanol into ethanoic acid, and there will be release of water molecule. From methanol can also be prepared, like if we are taking methanol and adding here CO, carbon monoxide, in the presence of iodine, rhodium catalyst, it can be easily converted into ethanoic acid. The important physical and chemical properties will be like, among the physical properties, ethanoic acid is a colorless liquid. Okay, with sour taste, as we have already discussed this physical property in our junior classes. And it is miscible with water. It boils at about 391 Kelvin. And in among chemical properties, what are the important chemical reactions it shows? The chemical reactions, important chemical reactions shown by acetic acid, first is the acidic nature. It shows the acidic nature. Okay, here, like, acetic acid can be easily combines with sodium to form. Here it is showing the it is showing, sorry, the substitution reaction. It is showing the substitution reaction CH3CONA, as we have already discussed as students. Here it is sodium ethanoate. This is sodium ethanoate formation with the evolution of hydrogen gas. So reaction with metals evolve hydrogen gas, and hydrogen gas can be tested easily with the help of pop sound. If you take a burning matchstick at the mouth of the test tube, then it will burn with the pop sound. So most often the testing of hydrogen carbon dioxide is asked in your exams. Keep it in mind, students. Next is neutralization reaction. Okay, acidic nature, what we have discussed here is the chemical reaction with metal. How will you show the acidic nature? How will you show the acidic nature of an carboxylic acid? Okay, how will you show it? If you dip the litmus paper in carboxylic acid, it will show the color change. Okay, blue litmus will change into red. This is how the acidic nature can be shown, as it is releasing the H positive ion. And this is second reaction in which we are showing the substitution reaction, in which H positive ion is released, and it is taken up, this H positive ion is substituted by sodium ion. Okay, two reactions we have considered here. The third one is neutralization reaction. Neutralization reaction in which the ethanoic acid CH3COH combines with NaOH to form CH3COONA, sodium ethanoate, with the removal of water molecule. Okay, the reaction is called as neutralization reaction. What are neutralization reactions? In which we are combining acids with bases to form salt and water. So these are neutralization reaction. Suppose if we are taking the example here of any carbonate salt, we are reacting here with carbonate salt. Take the example of sodium carbonate. Then here sodium acetate with carbon dioxide and water is formed. Carbon dioxide gas is released. How can you test here? When you pass carbon dioxide gas through lime water, it will turn it into milky. Okay, so this is how you can test for this is how can you test for carbon dioxide gas evolving out from a test tube when you are reacting sodium carbonate with acetic acid. The next reaction you can do for the chemical reactions of acids is the reaction with alcohols. That is the esterification reaction. Okay, how can you perform the esterification reaction? We have already discussed here, students, the esterification reaction. How can you do it? The esterification reaction can be easily carried out when you are reacting acid with alcohol in the presence of conc H2SO4, which will lead to the formation of ester, which is here methyl ethanoate, because we are reacting methanol with acetic acid with the formation of water molecule in the presence of acidic conditions. So this is basically the types of chemical reactions which are shown by ethanoic acid. And this is how you can test also. If you are asked for lab test for carboxylic acids, how can you show some lab test? Okay, the first lab test you can do the litmus test, in which blue color changes to red, Second test, you can do the esterification, as we have already done here, esterification reaction. The third test you can do here is sodium hydrogen carbonate test. Sodium hydrogen carbonate, when you are reacting it with like you are taking acetic acid and you are reacting it with sodium hydrogen carbonate, it will form, what it will form, students, it will form CH3CONA with the evolution of carbon dioxide. So you can test here with this carbon dioxide gas, passing it through litmus paper, it will turn in, passing it through when you are passing carbon dioxide gas through litmus when you are passing carbon dioxide gas through calcium hydroxide, it will turn into milky. Okay, so this is how you can test it. And a esterification reaction, in this is the esterification reaction you have discussed here. And in this esterification reactions, pleasant smelling compounds are formed, and this can be tested with the smell, pleasant smell. Okay, these three tests can be done for the identification of carboxylic acids. So here we have discussed all about the organic compounds related to carbonates compounds, students. The next topic that we are going to discuss here is the topic of soaps and detergents. Soaps and detergents. Okay, as you might have studied that basically any substance which is capable of removing grease or dirt from the fabric is called as detergent. But what is the basic difference between soap and detergent? Soaps are basically the sodium and potassium salts of carboxylic acids, sodium or potassium salts of carboxylic acids, then these are called as soaps. Okay, palmitic acid, oleic acid or stearic acid, you can take any value of R there, and these will be called as soaps. Let us try to understand the manufacturing of soap, students. How can you manufacture soap? Okay, what is the how can you do the preparation here? Suppose you are taking glycerol. Take the example of glycerol. This is 1,2,3 triol. Okay, trihydric alcohol or trihydric alcohol. The common name is glycerol. In glycerol, there are adjacent OH groups present on 3 carbon atoms, and when we do the reaction with uh, 3 moles of carboxylic acid, so what will happen here? Basically there will be the removal of water molecule, and here see, the 3 water molecules are removed and rest of the groups will be joined here as glyceride. See here how the formation of glyceride is occurring. This is the formation of glyceride. Are you getting the point, students? Okay, are you getting how we are making it? We have just removed the water molecules. 3 moles of water molecules have been removed and rest of the groups have been joined. Join this oxygen with carbon, and this is the formation of glyceride. This is the formation of glyceride or triglyceride from glycerol. And this fatty acid, this is fatty acid and glycerol formation. From glycerol and fatty acid we have made glyceride and water. Okay, now take this glyceride, what you have taken here is glyceride, and add 3 moles of sodium hydroxide in it. Add 3 moles of sodium hydroxide in it. What will be there? There will be removal of see here how the cleavage will occur. RCO negative, RCO negative, RCO negative, Na positive and OH negative. From NaOH molecule, the positive ion will go with the negative molecule in the form of RCONA, and the rest of the molecule will be joined, and it will be the glycerol molecule, CH2OH, CHOS, CH2OH. This is glycerol molecule with the formation of soap molecule. Okay, so here we have discussed the formation of soap. Now what is the basic difference between soaps and detergents? How will you explain the basic difference between the soap and detergent, student? How will you explain it? Soap is basically not giving any leather or foam formation with hard water, okay, but detergents are giving easily foam or leather with the hard water. This is the basic difference between the soap and detergent. So how can you explain it with an example? Like suppose in hard water there are some salts of calcium and magnesium ions. From hard water, if we take the example of calcium ion, it will react with sodium salt of this carboxylic acid, which is soap, to form this kind of compound, which is called as calcium salt, and it is also called as scum. It is also called as scum, or it may be called as precipitates. These may be called as precipitates. See here, there is only one valency negative of this RCO negative ion, and one positive for Na positive ion, but for calcium there are two positive valencies. So you can balance by taking this acidic ion multiplying with 2. Okay, so you can similarly take the example of magnesium ions from hard water, and subsequently magnesium salt precipitates or scum can be formed, and you can easily test, lab test it. Lab tests are there, students. You can easily test them in the laboratory. How can you test? The different tests are there. Like if you are taking the 3 different test tubes and taking 3 different samples of water, in which first test tube you are taking distilled water. Take the same amount of water in 3 test tubes, 10 ml you are taking in 3 test tubes, but different sources are there. In first test tube you are taking distilled water. In the second test tube you are taking the well water, but with hard salt. Like you are taking here, in the second test tube you are taking hard water, okay, from well water you can take it. The next you can take here is the water having some added up salts. You are adding some salts of calcium hydrogen carbonate here, okay, calcium hydrogen carbonate you have added up in the well water. So different types of water you are taking up. Now when you are taking the soap solution with these 3 different kind of water, they are producing the different levels of foams or leather with them, okay. The different levels of foam indicating the hardness of water. You are now doing the comparative account of hardness of water. Different amounts of lather or foam will be generated in the 3 test tubes. In which test tube there will be the maximum amount of leather formation or foam formation? Can you tell me in which test tube there will be the maximum amount of leather formation? There will be the maximum amount of leather formation in first test tube, in which the distilled water with soap solution you have stirred out. So maximum leather or maximum uh, leather formation or foam formation will be there in the test tube A. In the C test tube there will be the hardness of water at its maximum limit. So the leather formation will be minimum. Maximum leather formation or foam formation is there, but here it will be the minimum leather formation or foam formation will be there. Okay, so this is how you can do the comparative account of cleansing capacity of different samples of water with soap. Now we are doing the cleansing action of soap. Cleansing action of soap is very easy to understand, students. This is how the soap is doing its action with water on dirt. Suppose you are taking the molecule of dirt on a fabric. This is oil or dirt molecule. You are applying the soap solution. Soap molecule is like in which there is a long hydrocarbon chain with the hydrophilic head. This is hydrophilic head of soap. Okay, hydrophilic head is water dissolving part, and this is hydrophobic tail. Hydrophobic is the water repelling part. Hydrophilic head and hydrophobic tail in case of soap, and this is hydrophobic means water repelling part, and hydrophilic means water loving part. This is water loving part. So when you are dissolving the soap solution in water to remove the dirt, it will align itself in such a way that the soap molecule is having the hydrophobic tail towards the dirt molecule, and its hydrophilic end, that is hydrophilic head, is dissolving in water. This is how micelle formation take place in case of soap action towards dirt. Okay, this is micelle formation when you are applying soap solution towards grease or dirt. So this is the typical soap action when you are cleansing the fabric with soap and applying it on the dirt or grease. Now finally, when there will be the formation of micelle, when you apply water, it will be washed away with the water molecule. All the micelle formation will be easily washed away with the water molecule, and the fabric gets cleaned away. Okay, um, and now we are discussing the next portion of our topic, which is here the advantages and the harmful effects of detergents. What are the advantages of detergents and what are the harmful effects of detergents? Okay, as we have already discussed. Okay, let us discuss the difference between soaps and detergent. You should know the difference between soaps and detergents. Soaps are the sodium or potassium salts of fatty acids, students. Okay, long chain of carboxylic acids, RCO negative, Na positive or K positive. So these are basically, soaps are basically the sodium or potassium salts of long chain of carboxylic acid. The ionic group here is CO negative, Na positive, whereas in case of detergents they are these are the long sodium salts of long chain of sulfonic acids. Here is the ionic part, SO3 negative, Na positive, or sulfonates, or sulfates. SO4 negative, Na positive. These are sulfonates, these are sulfates. Okay, so sulfonic acids or sulfates, sodium salts of long chain of sulfonic acids or sulfates, and these are called as synthetic detergents. These are also called as detergents or synthetic detergents. Soaps are not suitable for washing when there is hard water. They are not giving leather or foam with hard water, so it is not suitable to wash away in case of hard water. But in hard water they are working very good. Detergents are working good in case of hard water. Okay, the next difference is soaps are prepared from animal fats or vegetable oils. Vegetable oils or animal fats, so these are natural sources from which they are formed, but these are prepared from hydrocarbons like petroleum. This is also a natural source, but as it is formed, it takes a long time. Petroleum takes a long time, almost millions of years to form. This is how synthetic detergents can be formed. The next one is soaps are biodegradable in nature. Biodegradable, what is the meaning of biodegradable? That can be converted into simple substances very easily with the help of enzymes, can be mixed easily into the uh, our soil, water and air easily. Simple substances, it can be easily converted into simple substances. But detergents are non biodegradable means they cannot be converted into simple substances. Okay, and this is the disadvantage also. Non biodegradable nature of this detergent is an disadvantage for using detergent. Okay, uh, and if we take one another point of soap is soaps have very poor cleansing action, but detergents have very good cleansing action. Okay, now we have gone through almost our whole of the chapter of carbon and its compounds, discussing almost every point that should be taken into account for discussing the important questions, important notes, and important yeah, everything we have included, like nomenclature, classification, the types of properties the carbon shows that make it different, distinguishing it from other elements. So here we end up with our important carbon its compound chapter, class 10 chapter. Hope the chapter will work out good with all of you students. If the video, if you are finding it useful, then go with the thumbs up button, share with your friends, and subscribe the channel if you have come for the first time. Okay, and we are coming up shortly with the next video. Till then, goodbye students.